phase shift oscillator. R the resistor, C the capacitor forms the feedback. So in this circuit we have three RC networks. These three networks will be given as feedback to the transistor. Each RC network gives 60-degree phase shift. Totally we have 180-degree phase shift, which is given as input to the transistor. Here we are going to find the frequency of oscillation. So these are the components used. We use 4.7K, 6.5 kilo ohm, 1.5 kilo ohm, 1 kilo ohm, 1 microfarad, transistor BC107 and capacitor 0.01 microfarad. This is a breadboard. We are going to give connections in this breadboard. These 5 holes are connected to each other. Same way, all the vertical 5 holes are connected. Same way, vertically, here this rows, these 5 rows at the bottom, 5 rows at the top are connected. So these are separate connections. This here they have separated. Another 5 rows they are connected. Next 5 rows are connected. Same way at the bottom. Now we are going to give connection. Let me first connect the transistor BC107. Keep the projection part towards us, and this forms emitter, base and collector. Now I'm going to give this transistor so this forms emitter, base, collector. Let us first connect the emitter part. In the emitter, I am going to connect 1K. This is an 1 kilo ohm resistor. Next, I am going to give 1 microfarad. Capacitor. So in this capacitor, it has 2 leads. One lead is longer than the other. Consider the longer lead as positive and the shorter lead as negative. So the positive part I am going to give in the emitter, and the negative part I am going to keep this as ground, this part. This is the regulated DC power supply. Here the negative part I am going to give the negative connection to this ground. Now let us connect the collector part. The collector I'm going to connect 4.7K. Let me keep the upper part for supply. The positive of this supply I'm going to give to the collector circuit. Now I'm going to connect the feedback part. Capacitor 0.01 microfarad. Connect in the collector and any one hole. Next capacitor, any one in the 5 holes and to any other hole. Same way, another one capacitor to any one hole in the 5 holes and any other hole. I'm going to connect 6.5 resistor to any other hole here, and I'm going to connect 1 microfarad positive of the 1 microfarad keep in any one of the 5 holes here, and the negative to any other hole. Now this feedback I have to give the circuit to the input. I'm going to take a wire, connect the capacitor. It goes to base of the transistor. Only the capacitance we have connected. We have to connect the resistor part. I'm going to connect 6.5K. I can ground the 6.5K. Another one 6.5K. Ground at 6.5K. Now we have to connect resistor, $7.5K. From the source, from the supply to the base. Another one resistor 1.5K from the base to ground. Now the circuit connections are over. I have given positive and negative supply, and negative I have grounded. Output of the circuit is viewed in CRO, cathode ray oscilloscope. This is a CRO. Have connected probe. Let me ground the negative part. The positive part of the CRO is connected to the collector of the circuit, collector of the transistor. Keep the supply to 12 volt. We are able to get the output sine wave. Now we can take the readings. We can calculate the voltage and the time. Voltages, we have to calculate the number of boxes. So this knob I can set to 1 volt. So it comes to nearly 1 box plus 0.6. Each will carry 0.2, 0.2, 0.2 divisions. This comes to 1.6 into 1 volt. Time divisions, here I can set to 1 millisecond. Here it comes to nearly 1 box, 1 cycle, 1 positive cycle and a negative cycle can take as 1 box. So 1 into 1, 1 millisecond. Now we can calculate the frequency of oscillation. Thank you.